In section 3.3, we revisited how to find a slope, whether it was from an equation or a graph or a set of points. Today we're going to talk about parallel and perpendicular slopes. And I'm realizing that really this should be section 3.4, so I'll fix that. All right. So this is again something you did learn in algebra, and so hopefully it feels like a review. So lines which are parallel have the same slope. And so again, we might have a graph, we might have an equation, we might have a set of points, or we might just be given the slope. And we're going to compare the slopes based on all of those conditions to see if they're the same, and then we'll say they're parallel. Or if they're opposite reciprocals, and then we would say the lines have perpendicular slopes. Let's talk a minute about that word opposite reciprocal and what that actually means. So if I give you some examples of opposite reciprocal slopes, it would be something maybe like -5/6. You know what? I see that one down below. Let's do a different one. How about -3/4 and -4/3? Those would be opposite reciprocals because they have opposite signs. That's what the word opposite means. One of them's negative, one of them's positive. And they're reciprocals, meaning one is the flip of the other. So if you have 3/4, if you flip it, you get 4/3. So you need both of those conditions for slopes to be perpendicular. You need them to be both opposite and reciprocals. Another way that might look would be, what if you had a fraction? What if you had 1/2? Well, if you flip a fraction like that, you get a 2/1 or a 2. And remember, they have to be opposite, so one of them would have to be negative. So maybe you have something like 1/2 and -2. And again, remember that -2 could have a 1 underneath it, and that's why they're considered reciprocals. But you won't show that one, right? That one won't be showing. Another thing that's opposite reciprocals that might not look like it is a 1 and a -1. That's because if you take a 1 and flip it, it stays a 1. So that those are considered reciprocals, and again, they have opposite signs. So all three of those are examples of what an opposite reciprocal set of numbers might look like. All right, so if we go to example 1, it says determine if the lines are parallel, perpendicular, or neither. And in example 1, they gave us the slopes. So all we have to do is compare those numbers and ask, are they the same or are they opposite reciprocals? Or maybe they're neither of those things. So in example 1a, 5/6 and -6/5, those are opposite signs and they're the flip of each other. And so that means they are opposite reciprocals, and so they're perpendicular. Now I'm going to write out the words in these notes, but if you want to use a shortcut way of saying perpendicular, let me put it up here. You can put an upside down T. That means perpendicular. If you want a shortcut way of saying parallel, you can put a double set of lines right next to each other. So if you want to write an upside down T instead of that long word perpendicular, that would be fine. But again, for these notes, I'm just going to write out the word. All right, in example 1b, it says one of the slopes is 4/3, and line 2 also has a slope of 4/3. Those are exactly the same numbers, so we're looking at parallel slopes there. In example 1c, one of the lines has a slope of -2. The other one has a slope of 1/2. We even talked about that up above, right? If you have a 1/2 and a -2, you do have opposite signs, and one of them is the flip of the other. Because remember, any whole number could have a 1 underneath it, and that's why they're considered reciprocals. So I do have opposite reciprocals in C, and so we're going to say those are perpendicular. And then finally, in example 1D, we have a slope of 7/8 and a slope of 8/7. And that one's trying to be tricky because we do have reciprocals there, right? One is the flip of the other, but we do not have opposite signs. And so that's considered a neither situation. Those lines are neither parallel nor perpendicular. So you'd want to write neither. So be careful again. Remember that for perpendicular, you have to have two conditions. You have to have both opposite signs and reciprocal numbers. Parallel is easy because it's just the same slope. All right, so in example 1, the slopes were given for both of the lines, so we just had to compare the numbers. In example 2, the slopes are not given. Instead, there's some graphs given. And so they said, what is the slope of line 1? And they didn't really label either one of them 1 or 2, so I'm going to call the top one 1. What's the slope of line 2? So I'll just call the bottom one 2. It really doesn't matter which one you call 1 and which one you call 2. You're still just going to try to figure out the slopes and compare them, so it doesn't matter. Now, when there's not a point on the line, what you're going to want to do is because remember, we're going to count squares, right? We're going to count squares from point to point. So you're going to put a point on any line that crosses right over a grid mark. And a grid mark, again, is where these two, like any of the two gray lines meet, those light gray lines, wherever those meet up, and then the red line crosses right at that intersection, you're going to want to put a point there. And so now you just got to pick another place where that happens. So I'm going to, on line 1, going to pick this second spot right there. So notice they're crossing right at like a crisscross mark on our graph. So remember for that, if we're going to have a graph, we can just count squares, and we're going to say how much did we rise and how much did we run. Well, you rose up 1 and you ran 1, 2, 3, 4 squares. So again, count squares. You went up 1 and you went over 1, 2, 3, 4 squares, right? So rise over run. Slope of line 1 would be 1/4. If we switch over to line 2, we're going to do that same thing. We're going to pick 2 points. So I'm going to pick one down here at -1. And then this one over here at 4 looks like it crosses right on the crisscross mark. So if you count squares again, you're going to go up 1 and then over 1, 2, 3, 4. So this is a positive 1/4 slope for the second line. Those have exactly the same slope, right? 1/4 and 1/4. So the answer is parallel. All right, so if you're given a graph, just count the squares. All right, let's try it again. So we're going to look at line 1 versus line 2. You can call whichever one you want 1 and whichever one you want to call 2. It doesn't matter. We're just going to compare them anyway. So I'm going to call the top one 1 and the bottom one 2. Now I see they did put a point here, right? So hopefully you're seeing this point right here. And then I see another place where it crosses over right there. And if I count those squares, I'm going to go up 1 and over 2. So I have a rise of 1 and a run of 2. If we look at line 2, I see a point again, same spot right here where they touched, but then also down here at the -3 on the second line. So we're going to go down 1 and right 2. And we went down, right? So if you're going down, you're in the negative direction. So you went down 1 and then you went to the right 2. So you have a positive 1/2 and a negative 1/2. Remember that you have to have opposite reciprocals. We don't have reciprocals. We only have opposites. And so again, this is going to be neither because they're not the same number, but they're also not opposite reciprocals. All right, there's going to be one more down here. Third example. Again, whenever they give you a line, just count the squares. So for the first line, I'm just going to call this top one 1 and this bottom line down here 2. For the one that I just called 1, I see this intersection point, and I see it also crosses the grid right there. And so I'm going up 1 and to the right 2. So another one with a 1/2. Up 1, right 2, rise over run. And then for the second line, if we compare, let's find another point where it crosses. So if we're looking at the second line, we could pick those 2 green points, and we're going to go down 2 and to the right 1. Again, we went down. So down 2, right 1. And if we simplify that, that's just a -2. In this case, we have opposite reciprocals, right? We have opposite signs, and we have the reciprocal happening. And so this would be considered perpendicular. All right, so in example 1, they gave us the slopes. In example 2, they gave us the graph, so we had to figure out the slopes ourselves. So let's see what's happening in example 3. In example 3, they gave us equations. So again, this is a review of Algebra 1. And when we have equations that are written in y equals mx plus b form, we should know that the number in front of the x is our slope. And so many of the equations in example 3 are written already in y equals mx plus b, so the slope's going to be really easy to find. And on the equations where it's not written in y equals mx plus b, we're going to have to rewrite them. But let's get started with the first few. So in the first few, in example 3a, I see a slope of line 1 is right there. It's 1/5. And the slope of line 2 is -5. Those are opposite reciprocals, so that's perpendicular. So I like it when they write the equations in slope-intercept form, in the y equals mx plus b form, because there's really not that much work to do. You just have to, again, identify the slopes, which in this second example in B, we have a -2 on line 1. And in line 2, we have a +2. Again, the number in front of x will be your slope. In this case, we have opposites, but they're not reciprocals. So in this case, we have a neither situation. They're not parallel or perpendicular. If we come down to example C, the first line is going to be easy. The slope is 4/5. The second line is going to take a little bit of work. That y is not isolated, so we're going to have to divide everything by 5. And if we rewrite that equation, we're going to get y equals 4/5 x minus 2/5. And so that slope is what's in front of the x as long as the y is isolated. So we had to do a little bit of work. We had to get that y isolated. And so now that we did, we see that that slope is also 4/5. So they both have the same slope, exactly the same, and that makes those lines parallel. All right, one more example. This one takes the most work because we're not in y equals mx plus b form for either one of these. So if we start with line 1, we got to rearrange that. We're going to need a little bit of room, so I probably could have spaced this out a little better. So if I rewrite this up here, 3x plus 2y equals 10, I'm going to have to subtract the 3x because remember, we're trying to get y by itself. So let's get that 3x out of there, and we have 2y equals -3x plus 10. I'm trying to rewrite it so that the y is isolated, and the other side looks like something in front of x and then a constant. So I'm keeping that x term first. And now I'm going to divide by 2. And I end up getting y equals -3/2 x plus 5. Now that I have the y isolated in line 1, I know that that slope is that -3/2. So that's going to be my slope for line 1. Again, that took a little bit of work, right? The second one, line 2, we're going to come down here and do it. Let me just rewrite it. -2x plus 3y equals 8. And again, I have to isolate y. So I'm going to add 2x to both sides. And I get 3y equals 2x plus 8. And then I'm going to divide by 3. So bring your x term over and then divide by that number that's in front of your y. And so we end up getting y equals 2/3 x plus 8/3. Now that I have the y isolated, I can see my slope is right here. It is 2/3. And if I compare those two numbers that I just calculated, I have a -3/2 and a +2/3. They're definitely opposite signs, and one is the flip of the other. So again, we have a perpendicular situation. And that one just took quite a bit of work. So if I was going to give you one like that on a quiz or a test, it'd be only one. I would never give you more than one of those. Okay? All right, so that's what happens when you have an equation. If it's written in y equals mx plus b form, then just look in front of the x to figure out the slope. And if it's not, you have to rearrange the equation to get it in y equals mx plus b form. All right, the last example, example 4, if we're trying to determine if the lines are parallel, perpendicular, or neither, and all they do is give us points, well, then we're going to have to calculate the slope just like we did in the last section where we used the slope formula, which was slope equals y2 minus y1 over x2 minus x1. All right, so if we use that formula for line 1, so let's do it. I'm going to just put an m for slope, and then I'm going to put a little subscript of 1 for line 1. So I'm going to go up to here to line 1, and I'm going to do the slope formula on those points. Remember that we have an x and a y, we call that 1, and then we have another x and y, and we call those 2. So on the slope formula, we're going to go negative 10 minus 6. We're going to subtract the y's on the top. On the bottom, we're going to subtract the x's. We're going to go 6 minus 20. Now watch your signs, right? Get your calculator out if you're bad with signs. This is going to give you negative 16 over negative 14. A couple things to remember from algebra. If you have a double negative, it's really positive. So this is really like 16 over 14 because of those two negatives. Final thing to remember about algebra, though, is you should always reduce your fractions. So if you divide top and bottom by 2, you're going to get 8 over 7. So slope of line 1 is 8 over 7. If we go down to the next line, line 2, again you have an x1, y1, and you have an x2, y2. So due to the slope of that line, I'm going to give an m again, but I'm going to give a subscript of 2 because we're talking about the second line. And we're going to do the y's on top. So we're going to do negative 7 minus 0. And on the bottom, we're going to do 3 minus a negative 5. Remember, the formula says to subtract, and you're subtracting a negative number. Again, that's a lot of negatives, so if you're bad with negatives, get your calculator out. Negative 7 minus 0 is just negative 7. A 3 minus a negative 5. Remember what happens when you have double negative. It's really plus a positive, right? And again, your calculator knows that, so maybe just use your calculator unless you're good with that kind of subtraction. And you would get a positive 8 on the bottom. So the slope of line 2 is negative 7 over 8. If you compare these two numbers, 8/7 and negative 7/8, they are opposite signs. They are the flip of each other, so that means they're perpendicular. Seems like we like perpendicular in these notes. All right, last one. Let's try one more. The slope formula. So for this first line, we're going to do the slope by using the slope formula up above. We're going to subtract the y's, 16 minus a negative 17 on the top. We're going to subtract the x's on the bottom, a negative 9 minus a negative 20. Look at all those double negatives. Be careful with those. So on the top, it's really like plus a positive. On the bottom, it's like plus a positive. So on the top, we end up getting 33. On the bottom, we end up getting 11. 33 over 11 can be reduced to a 3. If we switch over to line 2 and do the slope formula again, we're going to get negative 12 minus 3. Again, I subtracted the y's on the top. On the bottom, we're going to get negative 19 minus negative 14. Again, look at those double negatives. On the bottom, that double negative is like plus a positive. On the top, we don't have any double negatives in a row, so we don't have to do that. All right, so the top becomes negative 15. The bottom becomes a negative 5. If we take a negative 15 divided by a negative 5, we get 3. So our slopes are identical, right? We have a 3 and we have a negative 3. I'm sorry, we have a 3 and a positive 3 and a positive 3. And so those are parallel slopes. Okay, so example 4 was probably maybe the hardest kind of problem where I give you the coordinates and you have to figure out what the slopes are using the slope formula and then compare the numbers. If we back up again, example 3 gave you the equations. So find the slopes by getting it in y equals mx plus b form. In example 2, all we did was count squares, right? We had to count squares to figure out the slopes because they gave us the graph, and then compare them. In example 1, they just gave us the slopes, so we just had to compare them. We didn't really have to do any work other than comparing them. And just remember that parallel lines have the same slope and perpendiculars have opposite reciprocals.